Assalamualaikum and hi, I am Muhammad Firdaus bin Sudianto. My matric number is B0918102119. My program is BMMH and my supervisor is TS Azwan bin Aziz. This is my slide for PSM1. My project title is the prototype design of the vehicle carbon monoxide detector in bracket VECOD with a low cost sensor using Arduino Uno as a platform. There are some content that will be available in this slide. Among of them are introduction, problem statement, objective, scope of project, literature review, methodology, expected outcome, Gantt chart, and the last one is reference. In the methodology, there are several sections. Firstly is components, second is the design of VECOD system, and the last one is final outcome of VECOD prototype. Introduction will explain a little about carbon monoxide. Carbon monoxide in bracket CO is one of the gases that pollutes the air and is known as a toxic gas. This is because CO gas are colorless, odorless, tasteless, invisible and poisonous gas that can be fatal when inhaled into the human body. CO is poisonous gas was produced from incomplete combustion of fossil fuels, for example, combustion in a car engine. Inhaling carbon monoxide gas over a period of time and be in an enclosed place can cause serious health problems, as well as can lead the death due to CO poisoning. CO is also known as a silent killer because of its no signal presence. The most common cause of CO poisoning is stay or sleep in a vehicle with an engine running, where carbon monoxide leaks occur from the exhaust system into the vehicle, door hole or windows or doors. This is the problem statement of the project. Is the case of sudden death while sleeping in the car has worried the Malaysian communities and the authorities due to CO poisoning. This happened because we are not aware that we are being poisoned with CO gas in the event of a CO gas leak in the vehicle. For information, among the cause of CO poisoning in vehicle is because there is leakage between the exhaust connection and the engine. Therefore, the gas exposed to leak will enter the car cabin space, though the air conditioning system and small space. For this reason, many people misunderstand that they say the air conditioning system is the cause of CO poisoning. But the real case of CO gas poisoning is due to leaks that occur in the connection between the exhaust and the engine, as well as leaks in the exhaust duct system of the vehicle itself. The available picture shows several cases of the that occur as a result of CO gas poisoning. This proof that CO gas is a toxic gas that is so dangerous that it can be deadly. Therefore, it's time all vehicles are required to use a device that can detect CO gas. So, VECOD system is very suitable to be the first choice of consumer to get it because of its cheap price and quality. The objective for this project are divided into two, namely general objective and specific objective. For general objective is to design a fabricate a CO detection system with a low cost for average car owners. While for specific objective to analysis the existing CO detection system and to develop a carbon monoxide detection system to prevent carbon monoxide poisoning in vehicle. Scope of project, firstly, this device is specially made to be installed for road user who use motor vehicles such as cars, buses, lorries, and so on. Next, this project is also an initiative to create a low-cost carbon monoxide detection device. So, That's all consumers can get it in an effort to prevent deaths involving carbon monoxide gas in cars. After that, the scope of the project can be divided into two parts, which the hardware and the software. For the hardware, I use the Arduino Uno R3, CO gas sensor in bracket MQ7 and others. While the Arduino Integrate Development Environment in bracket IDE is used to program the system in the software section. In the literature reviews, there are some subtopics related with the project. Firstly is carbon monoxide. According to a study, particularly 70% of carbon monoxide are released from motor vehicle. CO personally is hardly identified because its clinical symptom non-specific. Then effect of carbon monoxide on the human body. Significant exposure of CO may lead to heart danger. CO poisoning is the most common type of fatal of air poisoning in many countries. On average, the exposure at 100 ppm or more is dangerous to human. Next, source of carbon monoxide from vehicle. An exhausted gas penetrating inside the vehicle through the backside leaking part of the vehicle instead of going out through the exhaust pipe. Then catalytic converter. Leaks can also occur at connection between engine, manifold, exhaust pipe, catalytic converter, or on the components themselves, causing a lot of carbon monoxide to be released. After that, metal oxic semiconductor based CO sensing. Then electrochemical gas sensor, and computer based carbon monoxide monitoring system. And the last one is microcontroller based carbon monoxide monitoring. Flow process for the vehicle system. There are two sensors in this system. Sensor 1 of which will be placed at the connection between the exhaust duct and the engine. The second sensor will be placed in the car cabin. When the CO sensor detects CO gas according to the predetermined reading, the reading will be shown on the LCD. If there is a leak in the sensor 1, it will emit a yellow light signal who wants to tell the user that they need to make maintenance on the connection of exhaust and engine. While when the sensor 2 detect carbon monoxide gas in the cabin car, it will show a red light, and at the same time will emit a sound from buzzer to alert the user that they are in the In components, they are the main components that will be used in the vehicle system. We have an Arduino Uno R3 that will receive signal from the input system and transmit the signal to the output system. Next, CO sensor in bracket MQ7 will act as input system that detect carbon monoxide gas. After that, LCD function is the display CO gas reading and current condition, whether in good condition, warning, and dangerous. Then the buzzer will emit a sound to alert the driver or user. And the last one, LED also serve as a tool that will alert user whether they are in a safe state, warning, or dangerous though the reflected lighting that is green, yellow, and red. This is the design of vehicle system for the project. In this part is divided into two. There are block diagram of vehicle system and project circuit design. For block diagram, show the input system and the output system found in the vehicle system. The input system consists of a DC power supply and the carbon monoxide sensor in bracket MQ7. Arduino Uno R3 will play the role of the microcontroller that will control between the input system and output system, while the output system consists of LED, LCD display, and buzzer. Each will respond after the signal is sent by the microcontroller. In this system, the green LED light up if the situation is safe or normal. The yellow LED will illuminate if sensor 1 on the connection exhaust and the engine detect the CO gas due to leakage. This is to make a driver or user aware that there is a problem with the exhaust and engine connection. This method is to prevent the CO gas from entering the car cabin, as most cause occur due to leak and disconnection, which cannot be detected. After that, the red LED will light up after sensor 2 in the car cabin detect CO gas, which may be caused by the leak in the vehicle exhaust duct system below, and then enter the car cabin, door space or small hole of the vehicle. This is to inform the driver or passenger that they are in danger, because the environment in the car cabin is being filled with CO gas, which can be detrimental to the health of people who inhale it. LCD in vehicle system will show the the CO gas readings then have been detected, as well as the current status, such as good, caution, or dangerous. When the LED show on green, the LCD will display good status. Likewise, on the yellow and red LED, the LCD will be displayed with a warning and dangerous status. In vehicle system, the buzzer will alert the user by making a sound after CO gas is detected in the car, which is in a state of danger. The use of buzzer will help inform the user to the sound. Therefore, the user can act immediately to avoid CO poisoning. This is the final outcome of vehicle prototype. On this slide, show an overview of the final outcome of the vehicle prototype. On the upper surface will be visible LCD display and LED. There is also a hole on the top surface for buzzer to emit a clear sound. After that, it is placed on the top surface is to make it easier for user to see the response of vehicle system easily. Furthermore, on the front surface there is a hole where the second CO sensor will be placed for detect the CO gas. This is to make it easier for the sensor to detect CO gas more quickly. On the expected outcome, we'll explain about this vehicle system can exist in alerting the driver or user if carbon monoxide gas is leaking from the vehicle. Then this system can also help minimize carbon monoxide gas poisoning in vehicle, even though it's cheaper than others device. And the last one, for the time future, I hope that this technologies becomes a specialization on every vehicle to ensure that consumers are protected from carbon monoxide poisoning. Okay, this Gantt chart shows the activities that have taken place throughout the completion of PSM1. In this section, show some of the references for this project.